Okay, now we'll move to the next concept about an acid, which is Bronsted-Lowry concept about an acid. Unlike Arrhenius' concept, he defined an acid to be any substance that dissolves in water to produce hydrozonium ion. Yes, Arrhenius' concept has a limitation. Yes, and its limitation is that it limits an acid to an aqueous solution. Yes, an acid will behave as a what Arrhenius is saying that without an aqueous solution, an acid cannot perform. I hope you understand. So Arrhenius it limits an acid to an aqueous solution. Okay, now but in Bronsted-Lowry concept is another way around. Okay, Bronsted and Lowry they gave their own definition about an acid and a base. They define an acid as a substance that what that donates proton. Okay, a substance that donates proton. So they define an acid to be what? To be a proton donor. Okay, to be a proton donor. So Boston and Lawrence define an acid to be what? To be any substance that donates proton. And what is proton? Hydrogen what? Hydrogen ion. Okay. Yes. Then they define base to be a substance that accepts proton. In other words, proton. In other words, proton what? Acceptor. Okay. Yes. Now, if you look at this, you find out that hydrochloric acid e donated what? Hydrogen ion to what? To ammonia. When e donated an hydrogen ion to ammonia, e forms what? Okay, yeah, if you look at it very well, you find out that e donates proton to what? Ammonia. In the process, this substance is what? Is an acid because Bronsted and Lowry they said an acid they do what? They donate proton. If you look at this reaction, you find out that hydrochloric acid e donated hydrogen ion to what? To ammonia. Then same also ammonia here is what? Is the base. According to Bronsted and Lowry, a base is a substance that would accept proton. Find out that hydrochloric acid e donate proton to what? Ammonia. Ammonia do what? Ammonia would accept what? The proton. Okay, so if you look at this reaction, if you can recall, Arrhenius concept about acid and base has a limitation, and the limitation was that it limits an acid to aqueous solution, and there must be an aqueous solution first. When I mean aqueous solution, a solution that contains water, there must be water present first before an acid can behave as an acid. Yes, but in Bronsted concept was not like that. Yes, Bronsted concept, this concept didn't limit an acid to be to didn't limit an acid reaction to be in just an aqueous solution. I don't know if you understand. So Bronsted concept was above that. Yeah, if you look at this reaction very well, you find out that ammonia here is a gas. Yes. Hydrochloric acid, ammonia. I don't even understand. Do you see anything aqueous here? No. Didn't see anything aqueous. So Bronsted concept defined as the limit it didn't limit an acid to what? This concept didn't limit an acid to aqueous solution. Unlike Arrhenius that said that there must be water first. There must be water first before an acid can behave as an acid. Without water, the substance is not an acid. But Bronsted is saying no. Yes, an acid can still behave as an acid even outside an aqueous solution. Okay, so if you look at this very well, find out that hydrochloric acid donates what? Proton to ammonia. Ammonia in return accept what? Accept the proton. Now let's continue. uh, Same also under this Bronsted concept about an acid. Under this Bronsted concept about an acid. Now, eh, when an acid, please take note. When an acid donate a proton, eh, look at this very well. Okay, take note. When an acid donate a proton, it forms a conjugate base. It forms what? A conjugate base. Okay, when an this an in this reaction, this is an acid. When an acid donates what? A proton. If hydrochloric acid, now let's say when you remove the hydrogen ion, you'll be left with what? You left with what? Chlorine ion, abi? Yes. Now, when an acid donates a proton, it forms a conjugate base. It forms a what? A conjugate base. Okay? Yes. When an acid donates proton, it forms a conjugate base. Then, when a base accepts proton, when a base accept proton, it forms what? A conjugate acid. It forms what? A conjugate acid. Okay? Yes. Now take note that an acid cannot form acid and base, they cannot form their conjugate. An acid cannot form a conjugate without there must be a base present before an acid can form its conjugate base. Same also, there must be an acid present before a base can form what? A conjugate acid. I don't know if you understand. So when an acid donates a proton, it forms what? If you remove hydrogen ion from hydrochloric acid, you'll be left with what? Chlorine ion. Then if you add hydrogen ion to ammonia, you'll be left with what? Ammonium. You'll be left with what? Ammonium ion. Okay? So when an acid donates proton, it forms what? A conjugate base. When a base accepts proton, it forms what? A conjugate acid. Now, if you can, why are they called conjugate acid and why are they called conjugate base? Why is ammonium ion called what? Called a conjugate acid here, and why is chlorine ion called a conjugate base here? Now, if you look at this place very well, you find out that ammonium ion, it can donate what? It can donate proton to this guy, can donate proton to this one. I don't even understand. So that is why it's called what? A conjugate acid. Because why? Conjugate acid and conjugate base, they also have the property of an acid and a base. A conjugate acid donates proton. A conjugate base accept proton. I don't even understand. So these two conjugates, they can react together to form this one back. I don't even understand. So a conjugate acid has the property of an acid. A conjugate base also has the property of what? Of a base. Okay. When an acid donates proton, it forms a conjugate base. Now this conjugate base, if you look at it before, when an acid donates proton, it forms what? A conjugate base. Now this conjugate base has the property to what? To accept proton back. Okay. When a conjugate base accepts a proton, it forms the original acid. I don't even understand. When a conjugate acid donates proton, it forms what? The original base. So when this conjugate acid, it has the ability to what? Donate hydrogen ion to this guy. When it donates hydrogen ion to this guy, it will still we will come back to this very place. I don't even understand. So in summary, to everything under Bronsted concept is that if an acid to be a proton donor, a base to be a proton acceptor, then he said that when an acid donates proton, it forms a conjugate base. Conjugate base has the property of a base. When a base accepts proton, it forms what? A conjugate acid. Then then that means yeah. Then the limitation of Bronsted Lowry also has its own limitation about an acid. Now the limitation of Bronsted and Lowry concept about an acid is that it limits an acid to be any substance that contain proton. Yes. This is limitation of what Bronsted and Lowry concept. Even Arrhenius, Arrhenius, Arrhenius has it in fact has two limitations. The first limitation of Arrhenius concept is that it limits an acid to an aqueous solution. The second limitation is that it limits an acid to what? To be any substance that must have hydrogen ion. Then for Bronsted Lowry, it limits an acid to be any substance that has hydrogen ion. Are you understand? Look at the definition. An acid is substance that was donate proton. A base is substance that was accept proton. I don't understand. So Arrhenius and Bronsted Lowry concept about an acid, they both limit an acid to be a substance that contain hydrogen ion. In fact, Whereas there are associated substance that is an acid, but they don't have hydrogen ion. Okay, so we move to the next concept about an acid and base, which is what Lewis concept about an acid and base.